Okay, here we go. Good morning. We're going to work on absolute value equations today, and there's one main idea that we need to keep in mind today, okay? And that is, first of all, what is an absolute value and how do they work? And so an absolute value is going to, I need my handwriting to be better than that. An absolute value is going to look like this, two vertical bars up and down, and we'll put a number inside of there. And what these two absolute value bars do is they take whatever's on the inside and they turn it into a positive number. So this is literally going to take the 5, and once it takes the 5, it is just going to turn it positive. So it's going to turn from a 5, and this one's not going to change at all. It's just going to still be a 5, okay? If we have the absolute value of -4, all that this is going to do is it's going to take the -4, it is going to turn it positive, and it's going to turn it into a +4. Okay, so absolute values turn the number positive. Okay, what's the absolute value of -33? 33. Okay, literally just turning it positive. That's all the absolute value bars do. Now, that does start to, open up some options here, okay? And so if we look at what we've got here as the warm-up for number 1, if the absolute value of x equals 7, what are the possible values of x, right? And if you're really good at picking up on context clues here, right, you're looking at this values and you're realizing, why is this plural, okay? What numbers can we put inside the x to have 7 be our final outcome? Well, we could have the absolute value of 7, which is not going to change at all. It's going to turn it positive, and it's already positive. And so 7 is an answer, right? If we have 7 in the absolute value, that'll work. Or if we have -7 in the absolute value, that will also be turned positive. And so -7 is also a possible value that would work, okay? And so yet again, in Algebra 2, we're solving these equations, and we have 2 possible answers, okay? All week, every single absolute value question we solve will have 2 answers, and you have to find both answers, okay? Now, if we look at a question like number 2, the absolute value of x equals -4. What are the possible values of x? Well, if we put any number inside of the absolute value, it's going to turn it positive. So if we put anything inside here, we are guaranteed to get a positive number on this left side of the equal sign. This is guaranteed to be positive. Over here, we have a negative number, guaranteed. So is a positive number ever going to equal a negative number? No. Okay, this right here has no solution. And although we have 2 answers, whenever we have answers, it is possible that we have questions with no answers at all. Okay, and so it's pretty obvious when that's going to happen, right? If your absolute value of x is equal to a negative number, you just can't do it. So it's kind of like the square root thing, except for we're not going to include imaginary numbers. We get our steps here, isolate the absolute value and create 2 cases, solve both equations and check. Sure, let's go through a question and talk about what's going on here. Here is how I like to think about this. And in past years when I made videos, you might be able to find a video of me being very silly and drawing a whole comic book about absolute value equations. But what we're going to think about is that this absolute value right here, in my mind, we're not going to touch anything inside here until this absolute value is completely isolated, okay? And isolated is a word that means, on its own or completely alone. And so until this absolute value is completely by itself, we're not going to touch it. Now, here's the good news. It's already by itself, okay? And so if you look at number 1, isolate the absolute value, literally that just means get it by itself, okay? If we peek ahead to number 5, we can see that this 17 is on the same side as the absolute value, Okay, and so for number 5, time to move 17 before we do anything else. Okay, so step number 1 is really easy, especially for a question like number 3, because it's already done. It's already isolated. We're happy. Okay, now, here's where you got to kind of get big brain for just a second. Okay, what is this? And then taking the absolute value of that equals 5. Okay, and the way that this works, if we could get the inside, okay, if we could get x minus 9 to be 5, that would be good, right? Because if we could have a 5 right here, our answer would be solved, right? The absolute value, or our equation would be solved. The absolute value of 5 equals 5. That would be easy. But we have another circumstance. If x minus 9, if that x minus 9 was equal to negative 5, we would also be solved, right? Because that negative 5 would turn into a positive 5. And so basically we have 2 possibilities, okay? If we could get the inside to be 5, or if we could get the inside to be negative 5. And those are our 2 answers. Those are our 2 equations. And I'm going to set this up a lot of times with like kind of a T-chart, just to kind of keep myself separate, to help myself kind of find my 2 answers. There's another benefit to this. I'll tell you why in a second. Now from here, these are literally just Algebra 1 questions, and they're a piece of cake, honestly. Okay, all you need to do now is just solve these carefully. How do we get x by itself? You add 9. And I'm not going to be writing this plus 9 stuff, honestly, because we do so well in class. So one answer would be 14. Over here, we would have to also add 9. The other thing that's really nice about these questions is the way you solve the left is the same way you have to solve the right. On the left, you add 9. On the right, you also add 9. And so x is going to be 4. So there's your 2 answers. And if you look at what we've done, we have started by isolating. That was very easy. Created 2 cases, okay? So that's when we had, our left and our right 2 equations where one is equal to a positive number, one is equal to a negative number. And then we solved both equations. And then step number 4, check for extraneous solutions, okay? Now, we get this little box here. What are extraneous solutions, okay? Extraneous solutions are answers. This is really important if you're kind of zoned out here. Answers that look, I guess I need a bit more room. Let me zoom out a bit. Answers that look good that we find correctly, and then let me switch to red, I guess, here, but don't work. Okay, this is the one part of absolute value equations that kind of trips us up a little bit, okay? Sometimes answers that we get are totally normal looking. We found them without making any mistakes, and they just don't work, okay? Like we didn't do anything wrong. The answers just straight up do not work. Now, as you can see, number 4, it says check for extraneous solutions, okay? And so you kind of have a few different options, okay? One thing that you can do is you can go back and you can check your work, okay? So let's do this on the first one, okay? We're going to take the 14. We're going to have to plug it in to back where we had absolute values. And I know checking work is the most annoying thing in math. I know it is, okay? The absolute value of 14 minus 9 equals 5. And how I like to do this is just check this in your head, okay? 14 minus 9, that's 5. The absolute value of 5 equals 5. Check, okay? Now, another way that I like to check this, if you look up top here, the only thing that might go wrong is basically if we get a little twisted up and we end up with this type of scenario, okay, where we have an absolute value is equal to a negative number. And so if we go back down here and we go to check this answer, another thing that you can do is you can say over here on the left, this is going to be a positive number. And over here on the right, this is going to be a positive number. And so it's a good answer, okay? Now, if you do it this way, you've got to be sure that you did all this math correctly, right? Because another good thing about checking your answer is you'll find out if you did 5 plus 9 equals 15, right? Which would be incorrect. But if you trust your algebra, as long as you see positive equals positive, you're in good shape, okay? And so, you can see the same thing over here. Absolute value of 4 minus 9 equals. Now, here's where some people can trip up. They'll put a negative 5 down here. But remember, the reason I like the T-chart is because we need to check it at the top of the T-chart. Okay, so we need to plug that 4 in back up here where it's a positive 5. So then we get, again, a positive number equals a positive number, and we're happy again. Both of these answers are good. They're not extraneous, okay? Once we run into an extraneous answer, it'll be kind of obvious, like, okay, now I can, predict where those extraneous answers are coming from. Let's knock out number 5. And I'm going to go much faster here because, like I said, this is like mostly Algebra 1 type work. So I'm going to go pretty fast. So the first thing is this absolute value is going to basically be locked together. Okay, and I can't mess with this at all until it's all by itself. Okay, so the 17 has to go. So first thing I'm going to do is move the 17. I'm going to move it by subtracting 17 from both sides. And so I've got y minus 1. Absolute value bars in the ones. Obviously, gets a little tricky. So 23 minus 17 is 6. So now I've got this new equation where my absolute value bar is isolated. Here's what I would recommend. This equation up here is just worse version of this equation. Okay, this one is better. As long as you know you haven't made a mistake, right? I know 23 minus 17 is equal to 6. As long as you trust yourself with your simple math, I don't ever need this again. Okay, I like this version better. So now I've got this by itself. Now I'm happy that it's by itself. So now I'm going to make a little T-chart. I'm going to take the inside is equal to the number over here, and I'm going to take the inside is equal to the negative number over there. Okay? The inside could be 6, or the inside could be negative 6. Either one is a valuable answer. I'm going to solve them both the same way. This is the last time I'll do the little plus ones for you guys, but easy enough. So I've got 2 answers. Y equals 7. Y equals negative 5. And again, we kind of need to check for our extraneous answers. I like this T-chart because I know that I need to plug these answers into the equation that's right on top of the T-chart. And so I'm going to get the absolute value of 7 minus 1 equals 6. Absolute value of negative 5 minus 1 equals 6. And again, I kind of like to use the positive versus negative way of checking my answers. I know this side's positive. I know this side's positive. And so I'm happy. I know this side's positive. I know this side's positive. And so I'm happy. So both these answers work. Okay, now let's look at number 7. Again, moving pretty quickly. Are we isolated or not? Do we need anything to move? You guys tell me. Yeah, excellent job, my man Devin. Excellent job. 16's got to go. Now, how is 16 going to be moved? Very good, right? Think about it like this. This is a, locked up box. It's like a safe. And then this 16 is multiplied by the safe. And so in order to get the opposite of 16 times the safe, we need to do division. Right, so I agree 100%. Very smart. Dividing by 16. Dividing by 16. And so I'm going to get r minus 5 equals negative 2. Now we're isolated by ourselves. Okay, now we can do our little t-chart split. Now we can say the inside equals negative 2. The inside equals positive 2. Right? We basically are taking this answer, and then we've got one of the regular, one where we flipped it. Then we're going to need to add 5, which is going to be 3. Then we're going to add 5, which is going to be 7. And here's the thing. You may have caught on to this or not. These answers do not work. Okay? If this has surprised you, then you've realized why we need to check answers. If this has not surprised you, if you already realized that these answers were not going to work, then you're doing a great job, okay? And you're paying really close attention and you're killing it, okay? Look at this piece up here, okay? We've got absolute value equals a negative. Right now, we can already tell there are no answers. This side is always positive. This side is always negative. They cannot equal each other. No matter what, nothing we do, no answers will work. So, right away, if you're smart enough, or maybe not smart enough, if you are paying close enough attention, you don't have to do any of this. You can just stop right here if you notice that and say, no solution. Okay? Because there's no solutions. Now, what's going to happen is you're not going to notice it right there. Okay? I know that you guys are, a really smart class. You guys are killing it. Somebody is going to not quite recognize that that's a negative number. They're just going to keep going. And so then you go to check your answers, and you get the absolute value of 3 minus 5 equals negative 2. The absolute value of 7 minus 5 equals negative 2. And then you realize, oh, wait a second. Positive equals a negative. Does not work. Positive equals a negative. Does not work. Okay? Now, the reason I like checking the positive equals negative and I don't like doing the actual math is because if you notice, 7 minus 5 is going to be 2. And so the numbers should always line up. Okay? It's going to be 8 equals 8, or 2 equals 2, or 3 equals 3. And if it's extraneous, the numbers are still going to line up. It's just going to be the signs that are wrong, right? We've got 2 equals negative 2. And so the numbers themselves, as long as I trust that I know how to add 5, the numbers themselves aren't as much of a trouble as the signs. And so I like focusing on the signs. So anyways, this question has no solution. There is no way to solve this question with a number. Not even a complex number is going to work, right? We are totally out of luck here. No solution, no solutions, however you want to say it. Doesn't work. These answers are considered to be extraneous, a vocab word. Let me turn that one into an A. A vocab word that you want to try to remember, okay? And an answer that totally looks legit. We didn't break any rules, but it just doesn't turn out to work. Okay. What we've got now is, a couple different things. Let's look at a question like 8 and 10 just really quickly. Number 8, how are we going to move this 2 so that we can isolate our absolute value? How do we move the 2? Yeah, exactly. This is a absolute value that is being divided by negative 2. So how do you do the opposite of divide? You multiply by negative 2. So we would multiply by negative 2, and we would get the absolute value of y minus 10. Now we've isolated it. These two things have canceled out. And over here, we get positive 12. So a couple things. You can tell right away we're going to have real answers, okay? We've got positive equals positive. We're not in trouble of having fake answers. But another really important lesson, and I'm going way back here, if you look at this question, you might say, hey, wait a second. Absolute value equals a -6. Stop right now. We don't have any answers. But that's not the case, okay? That's why we need to isolate the absolute value. Because even though we have this is equal to a negative number, which we think means no solution, we have not isolated it yet. And this -6 turns into a +6 later on. Okay, let's just move on. Let's go and solve a question like number 11. Again, moving pretty quickly on this question here. We have this absolute value here. We've got two things that need to go. The 9 needs to go. The -4 needs to go. This is a trap question that you are guaranteed to see on the SOL, guaranteed to see on a test, most likely. How do you handle the 9 and the -4? They need to go to the other side, okay? Anybody have any ideas what we're going to do here? So it's a little bit tricky. So we have to remember how Pemdas works, okay? This right here is a +9 that basically needs to be added to something, okay? And this is a -4, and this -4 is multiplied, okay? This is kind of like if you want to make a new question that's very similar. This is like if we had 9 minus 4x equals -15, right? Let's just pretend that the x, or the absolute value, is an x, okay? Think about it like this. Now, how are we going to move to get the x by itself? What's the first thing that we need to do? We need to move this 9, okay? A lot of people will make a mistake and they'll say 9 minus 4, but you can't do 9 minus 4 because these two things are locked with multiplication, okay? You need to move the 9 first and do a subtract 9, and then you need to do a divide by -4, okay? You have to do it in this order or else, you're wrong. You're gonna get the question wrong. So let's go back. We need to start this question with a -9. You have to go this direction. You have to. Trust me. So we're going to get -4 times the absolute value of c plus 10 is equal to -24. Okay? Now we've started to isolate the absolute value, but we're not isolated yet. We still need to divide by -4 in order to cancel these out. And yet again, this -15, which might have scared us, ends up turning into a positive. Let me get a better color. Ends up turning into a positive number, 6. So, absolute value of c plus 10 equals 6. We should get 2 legit answers, okay? Because we have absolute value equals a positive. So, now it's time to split it up. And again, moving very quickly because this is literally Algebra 1. C equals -4. C plus 10 equals -6. C equals -16. Is everybody comfortable with how you get these two cases, right? I mean, you're just taking the inside equals +6, and then you take the inside equals -6. Because if the absolute value of a positive number would be 6, or the absolute value of a negative number would also be 6. So that's how you do it. Now, these two answers, we kind of know that these two answers are fine, okay? Because we have the absolute value is equal to a positive. So there's nothing to be scared of here. We could check them, sure. -4 plus 10, right? Your teacher might require you to check them. I'm looking at this. I'm still seeing positive equals positive. I'm still seeing absolute value of 6 equals 6. So I'm feeling good. Again, -16 plus 10 is equal to 6. Remember, we're plugging it in all the way at the top. So we need a +6 over here, not a -6. Anyways, the absolute value of negative 6, which is 6, 6 equals 6. Happy. Okay. Now let's look at a question like number 13. Okay, and this is where it's going to get a little bit harder for sure. Okay, this is honestly the first time that, this stuff's maybe not putting us to sleep all day. We have a question like this, and we have this. We have an x on the outside. Okay, now while that might not seem crazy, that is going to make a huge difference in our questions, a huge difference. And the reason is we know that this side is going to be positive, right? We know the absolute value guaranteed to turn positive. Over here, this is a really important kind of connection for you to make. This, we don't know if it's positive or negative yet. It might be positive or negative. If we plug in a 10, it's going to be positive. If we plug in a negative 10, it's going to be negative. Okay? And so this side is a mystery. And that means we do not know if we have good answers or bad answers. Okay? Like we have no idea yet. We're going to need to check our answers for real and take super serious, concern over whether our answers are going to work or not. So that being said, we're going to solve it the exact same way. Isolate the absolute value. It's already isolated. Go ahead and split it up. 3x minus 9 equals x plus 1. Okay, this side is basically the same thing without the absolute value bars. And then this side over here is a little bit tough too, okay, because we've got 3x minus 9, that's the inside, is equal to, and then when we normally do it, we've got inside equals positive, inside equals negative. For this question, we've got two things, an x and a plus 1. And so both of those need to turn negative, okay? A lot of people would do this, but this is wrong. This is a positive x still. Even the x needs to turn negative. So it has to look like this to be correct, okay? You need to turn everything positive, everything the same way. Sorry, that was a little bit of a misspoke by me. This needs to stay everything the same. This needs to say everything opposite. So it starts all positive. That means over here it has to be all negative. So that being said, I think I need another example because I didn't explain that super well. Solving this question really fast, we just need to get x by itself. I would probably subtract x, probably add 9. And so moving the x's over here, x's over here, that would be 2x. These 9s cancel out. That would make 10. And then x is equal to 5. Over here, I would do the same thing, right? I would probably add 9. But this time, it's not a positive x anymore. It's a negative x. So now I would need to add x. So you can see when you have the x's on the outside, it's going to trick things up quite a bit. These are going to cancel out. These are going to cancel out. That would be 4x equals 8 and x equals 2. Okay, so I've got these two answers. And they might work. They might not work. Maybe one of them works and one of them doesn't work. Okay, I have no idea if these answers are good or not. Okay, what I need to do is take them, plug them in up here, and again, I need to make sure that I'm going to have positive equals positive. Now, the other thing that's tricky is that this 5 needs to go into the x and the x, right? There's two x's, and so I need to make sure that my 5 goes into both of those as well. So this would be 3 times 5 minus 9 is equal to 5 plus 1. So what I like to look at is looking at this stuff here. I know that this side is going to be positive. And that is equal to, a positive on this side. And so this answer works. Okay, if I do the math here, that would be 15 minus 9, which is 6. Absolute value of 6 is 6. 6 equals 6. Correct. On this side, I need to do the same thing. I'm going to have 3 times 2 minus 9 is equal to 2 plus 1. I've got always guaranteed a positive is equal to 3, which is a positive. So this answer should work as well. So when we have an x on the outside, it makes things a lot more complicated. We're not sure if the answers will work. And sometimes they do work. Sometimes we get kind of excited like, ooh, maybe this one's going to turn out to be fake. Sometimes we check them and they just both still work. Let's do a question, and that one's kind of boring. Let's do a question like this. Going to go pretty fast here. Going to do 2 more questions and we're done with the notes. We need to isolate the absolute value. So the negative 5 in has got to go. I'm going to have to add 5 in, of course. And so I've got absolute value of 8 minus 2 in is equal to 6 in plus 2. Yet again, I'm just going to go ahead and cross this out because I don't need that version. I like this version better. I'm going to now split it up because I've got my absolute value isolated. I'm going to do everything exactly the same. So this looks exactly the same without the absolute value bars. And on this side, where these signs are the same, I need these signs to be opposite. So it's a positive 6 in, I'm going to need a negative 6 in. It's a positive 2, I'm going to need a negative 2. So let me erase that so I have a little bit more room to write. Okay, that would be 8 minus 2 in, and then the stuff on the outside needs to be swapped. Negative 6 in minus 2. Make sure you get this negative sign and this negative sign correct. Okay. Solving this very fast, I'm going to need to add 2 in. I'm going to need to subtract 2, so that's going to be 6, right? That's 8 minus 2. Add this 2 in. That's going to be 8 in. Over here, I'm going to want to add 2 in. That's going to be negative 4 in. I'm going to want to add 2. It's going to be 10. Now, on this question, you'll recognize that we have fraction answers. Okay. I'm getting 6/8 equals n, which of course is the same thing as n equals 3/4. And that is our answer. Over here, I'm going to need to divide by negative 4. And I'm getting n equals 10 over negative 4, which of course is n equals negative 5 over 2. And so I've gotten these 2 fraction answers, and unfortunately, unlike with your quadratics where we got fraction answers and we were just done, we're not done yet, okay? We need to work with these numbers, and we need to double check to see if these answers work or not. They might work. In the last question, they both worked. In this one, they might both not work. We'll have to see. So I'm plugging these in back to the beginning, and I need to make sure they go into both ends here. They've got to go into both of these ends. So, looking at the left one, 8 minus 2 times 3/4 is equal to 6 times 3/4 plus 2. I'll just go ahead and write this one as well, and then we'll talk about it in a second. All right. Again, this is a pretty important this is the first time we're really kind of struggling with fractions here. This is where you're really happy that we're just using the strategy of considering the signs, okay, and that we're not focused on exactly what the numbers should be, because this left side and this right side, the numbers will be the same, it's just the signs that might be off. So on the left, I've got an absolute value, guaranteed to be positive. On the right, I'm looking at all this stuff and just trying to figure out, is this going to be a positive number or a negative number? Well, I've got a positive times a positive plus a positive. It's all positive stuff. This is going to make a positive number. Nothing going on here could turn my number into a negative number, right? It's all positives being added together. It's going to stay positives. And so this answer, I like this answer. It works. 3/4 works. Now on the right side, doing the same thing, I know that the absolute value is going to be positive. And this is a little bit trickier, okay? 6 times negative 5/2 plus 2. Okay, so I know that when I multiply a positive times a negative, that's going to make a negative number. And so I need to decide, negative whatever this is plus 2, is that going to end up being a positive number or is that going to stay a negative number? A couple different ways. You could just do this using algebra. You could think about it like this, like the negative 6 times 5/2. 5/2 is going to be bigger than 1. So 6 is going to get bigger and it's going to turn into a negative number. So a bigger version of 6 that is negative, the plus 2 isn't going to matter. Okay, and this is going to end up being negative. You could do the math, right? You could say 6 times negative 5/2 is going to be negative 15. Negative 15 plus 2 is equal to negative 13. And so we've got positive equals negative. And so here, we've seen it. Okay, this answer right here does not work. This answer is extraneous. And again, a word that you want to try to add into your vocab. Extraneous. Okay, it doesn't work. We did all the hard work. We did the best we could. We did all the math correctly. It just doesn't work. Okay, so we have to be careful for those. The last thing I want to do really quickly is look at a question like this. And we're not going to finish the whole thing. Is this already isolated? Yes. So I'm going to split it up. Now, you might be thinking, well, we've got absolute value equals negative, negative. So maybe we could say this question just has no answers because we've got absolute value equals 2 negative numbers. The fact of the matter is, again, we're not sure if this is positive or negative yet because this W is a mystery. Okay, we might plug in a negative 4 here, and that would be negative 4 times negative 4, which is 16. 16 minus 2 is 14. So we'd have a positive number over here. So we don't know. We can't quit yet. We need to have everything exactly the same. And then we need to have the outside opposite. So our negative 4W would have to be a positive 4W. Our negative 2 would have to become a positive 2. And the stuff on the inside never changes, right? It's always still a 6W plus 20. Okay? You could solve this, blah, 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 and you get there. Now, I said that was the last one. I want to do the same. Give me literally 3 seconds here. I want to just look at what would happen if we had a question like this. Let me make a better question here. 2x is equal to x minus 3. Now, the reason I want to look at this is because we're already isolated. We can set up our two equations. I know it's going to be 2x equals x minus 3. But be careful over here. 2x is equal to, this stuff needs to be opposite. Okay? And that means the positive x is negative, and the negative at 3 is positive. Okay? These two things don't have to be the same sign, right? You know, they were the same sign in this question, number 16. They were the same sign in this question, number 15. But if we look at this one that I just made up, positive x negative 3, but then that needs to become negative x positive 3 on the opposite side. So, all of those things in mind, this is absolute value equations, okay? The main idea is that you're going to get two answers and you need to check them, which is easy if you have just a number on the outside, okay? If I just see that it's equal to 5, I already know these answers are going to work, okay? If I see that they're equal to 6, I already know that these answers are going to work. If I see that they're equal to negative 2, I already know that the answers are not going to work. It's when we have an X or a C or any letter on the outside that we get a bunch of problems, okay? We run into a question like number 13, and we're not sure if this is a positive or a negative number. We've got to check it out. Sometimes they both work. Sometimes they both don't work. Sometimes we get one good, one bad. Okay, that is absolute value equations. That's the whole thing. Yeah, that's the entire bit.